We're continuing our discussion around the sort of more non-technical artifacts with our project. So this is 2.3, architecture diagrams, and then system boundaries. This is the second last video in this set, okay? So let's just start by talking about why diagrams actually matter, right? So why even sit down and plan it out? Because up until this point in your computer science education, you probably didn't do this very much, if at all. Maybe you did when you took databases, if you took databases, but you know, in our sort of more standard programming classes, there hasn't been a lot of diagrams just yet. But could you imagine like going into a building, like an actual building, like, you know, into the engineering building here with no architect, no plans, nothing, right? That would be crazy pants. So these diagrams help us with our understanding. They can help support onboarding into a new area. So, you know, if you have a new person coming to work on a project, having diagrams can help them sort of understand what the project looks like right now. It can sort of connect back into team discussions. So as you're sort of setting up a diagram, deciding what's going to go where and having those conversations. And it's supposed to, and it should evolve. This isn't like something you do once and then put on the shelf and then it's there in case anybody needs it. It really evolves as time goes on. As your project changes and grows, so should your diagram. So in Comp 4350, Software Engineering 2, you're going to talk about even more types of, you know, architectures. But here in this course, we talk about an N-tier architecture. More specifically, we're going to talk about 3 tiers, or 3 layers, really. It's all going to live on one machine. This isn't going to be distributed in any sort of way, but we sort of aim for this idea of 3 separate packages of our code. We have the UI or presentation layer, we have the application or the logic layer, and then we're going to have our data or our persistence layer. And again, as our project grows, we will find that these layers sort of expand. We may end up with extra layers, but this is sort of our starting place and where we all want to start with our projects. So let's start by talking about the boundaries and responsibilities of each of these different layers. Let's take a look here. Imagine for a second that we were talking still about my Monster Buddy application, and I wanted to make a class called Scan Manager. So its job is going to be to control the methods like the number of seconds to show an animation for, or to check if the scan button is disabled. Where should we put this, right? So we're going to take a second. Hopefully you'll pause and you'll consider and come up with an answer in your head. Okay, when we talk about presentation and UI layer, we're really talking about presenting information, and that's it. We're not making decisions. We're not you know, changing what we're doing depending on the validity of our work, not within the scope of this course and this project. So our UI layer is strictly UI. So things like, is scan button disabled? That kind of a question, it doesn't really make sense for it to live in the UI layer, because we should already know if it is disabled or not when we head into the UI layer, right? Figuring out the number of seconds to show our animation for, that doesn't make sense either for our presentation layer, right? So Scan Manager probably doesn't belong in the UI. And now I'm going to skip over logic because, hint, that's where it lives. We're going to talk about our database and persistence layer. The Scan Manager, it doesn't make sense for it to live here either. We don't ask questions in the database layer, we answer them, right? We save stuff, we create new entries in our database, but we're not going to be asking sort of questions there. We'd be like setting the button to disabled if you needed some kind of a flag, or getting the status of our scan button, but we wouldn't be asking if it is currently disabled or not. So with that in mind, that's a question that we're asking. It makes sense for it to be in the logical layer. So is it disabled? If it is, right, we can return true for it being disabled or false. Otherwise, we can figure out based on that information whether or not we're showing the animation. Maybe if the scan button is disabled, we're showing 10 seconds of animation, and if the scan button is enabled, we're showing 0 seconds of animation. Something like that, right? That would be terrible, but like that sort of idea where we can see that the responsibility of this function is to manage the scan functionality, not display it, not get the information from the database, but just manage the behavior around it. So anytime we're dealing with behavior management, that is the logic or business layer. What about the scan ring view? So right here, so in my mind, I'm sort of seeing like this ever expanding ring that is scanning on my application. So the scan ring view is going to house the work for actually displaying the pulsating rings of the scan animation. So the big key here is the fact that I am saying actually displaying. Imagine that you're getting in front of a class to give a presentation. You don't stand there and kind of figure out while you're standing there, oh, should I show the next slide or not, right? You've already decided what your slide order is, and you are just displaying it. You're just presenting it. So scan ring view lives in our presentation layer. That makes perfect sense because we are just displaying this animation. When we make these diagrams, it should look basically like this. We should have our presentation UI with our arrow going to our logic layer, because the presentation UI layer is going to ask the logic layer for information. If the logic layer doesn't know it yet, it's going to head on over to the database layer, ask the database layer over here for information, right? So presentation to logic to database. And then very often we also end up with a fourth package up here of data storage objects, or just like an objects or models package with sort of any like bare bones object that we might need to use with our getters in it and stuff like that. So our diagram really just shows these major components and then their interactions between them. And then depending on what kind of technologies you're using, it really just depends on the setup. You might have like built-in libraries that you're using depending on the requirements of the project, like SQLite or JavaFX. You don't actually need to display those in our diagrams. However, if it helps you, you can, because for example, JavaFX should only ever be imported into the presentation UI layer since it's presentation UI specific. And SQLite should live over in the database persistence layer because it's only ever database or persistence layer specific. So there's no reason for the logic or business layer to have any kind of SQL or JavaFX imports in it. It should be totally separate, and that's a really, really important piece of building out our project in sort of a sustainable and flexible way. So here we can see that within each of these major boxes, we ended up with some smaller boxes, and each of these boxes represent a package, and really in our computers, a package is just a folder, right? So we're gonna have our presentation UI folder, and within it, we have another folder called views, and within that, that's where my scan ring view is gonna live. My logic or business layer, it's gonna have a folder called managers, that's where my scan managers lives. And then in my database or my persistence layer, I end up with two separate types of database implementations. I have a fakey one. We'll talk more about the fakey ones as we go, but we end up with this sort of fakey database with like pre-seeded data. And then we also have our real database, which will have an actual connection to, in our case, an in-memory database. So when you go about your project and you guys are starting to make these decisions and you have to go and draw out your architecture diagram, it needs to be legible, right? So I've pulled out a couple of sort of online options of tools that you could use, but you don't actually have to. You could draw it by hand, you could draw it like on a tablet and then just like export the PDF. It doesn't actually really matter very much. There's no specific tool that you're required to use when it comes to making your diagrams. All that matters is that your instructor can read it. That's it. Okay, so let's just quickly look at some anti-examples to wrap up this video on architecture diagrams. So these are real architecture diagrams that were done in class, in this 3350 class, that were handed in to me at some point over the last many years, that I saved just in case. So it's really hard to follow, which already tells us it's going to be like an anti-example. But we can see here that the dotted pink line is going to represent the major layers. So we have the presentation layer, the business layer, the objects, and then over here it's a persistence layer. The word interface also lives here. I don't know what it means. There's also a random arrow right here. I don't know what that arrow means either. Yeah, so we can already see that this doesn't make a ton of sense. We can see within the objects, I have to like get close to read it. It says feed user user guard log, maybe, user food log, oh, search log, food log, and exercise. So it's some kind of exercise app, but there's way too many arrows to know what's going on here, right? This doesn't actually help us all that much. So when you're making your diagrams, we really do want to think back to something that looks like this. It's much more simple. I don't have a bunch of arrows coming to and from my objects, for example. It's just not necessary, right? If I need to figure out where my objects are being used, I'll do it through the IDE. But trying to include it in sort of a 10,000 foot view architecture diagram just doesn't really make any sense. My other anti-example is this one here. This could be not terrible, but it sort of is for this example. Here we have an anti-example that involves sort of like a God class almost, where we can see every single class gets fed into a single service class, and then the service class is doling out the different information, right? So we can see things completely unrelated to each other. For example, account activity and profile fragments. Both of them are feeding into services. We have two very distinct groupings here. We have this or maybe even three. We have like account management stuff versus sports. We have iConversation DB. We have duplicates here, right? iUserDB, iUserDB. So they're trying to sort of model their interfaces and how their interfaces are connecting through their database and stuff like that. But again, this is one, too many arrows going into one box. And two, there's actually just more detail here than we even need for an architecture diagram. But you will notice it is a lot easier to follow than this one, right? So while they do have still more arrows than they probably need, they were really smart in not putting their like data storage object arrows everywhere. I'm pretty sure I can figure out that the user probably has something to do with the user database, and the message is going to have something to do with the message manager. So like picking really good names was enough for me to be able to make those connections. I don't have to figure out how to make those connections otherwise. I do like that this is color coded, but it really only helps us if we also have some kind of a legend that tells us what each of those colors mean. And if we did that, there's a good chance that that would even help us clean this up a lot, right? If I knew I was looking for a specific sort of flow, knowing that the flow I'm looking for is the green arrows, it would be a lot easier to sort of follow through. Okay, so with that, let's just take a quick second to pause and reflect. I want you just to sort of consider where your current group project is at, and I want you to sketch out that initial system diagram. You should have those 3 to 5 boxes, you should have some arrows, and then make sure you bring it into class so that you and your teammates can all compare. Do you guys have the same idea of what it is that you're gonna wanna be sort of doing with your project, your expectations of where things might live or how things might talk to each other? Or do you now have some new discussion points for your next group meeting, right? So having this discussion nice and early is really gonna help you and your teammates build a more cohesive and functional application at the end of the day. So take some time to do that and bring it to class, and I will see you in the next video. Thanks, everybody.